Hi, welcome to Flite Test. I'm Josh, and today we're going to be showing you how to build the FT Bloody Wonder. Now, if you guys haven't seen the FT Bloody Wonder, basically is an incredible design based off of Bloody Mick's Fun Bat. It was actually the very first scratch build review we ever did. And Bloody Mick, thank you again for the great design. And going back even further, SIG actually made a gas-powered plane very, very similar, and that's why we named it the FT Bloody Wonder. Bloody Wonder being for Bloody Mick, and the Wonder being for the SIG Wonder. But if you haven't seen the review of this, I definitely encourage you to go see it. It's a great combat ship. It has vertical takeoff capabilities. You can still put a landing gear on if you want, but it'll also fly off of the small 24-gram motor, or if you really want to get some speed for combat, go ahead and pop on this little Hobby King motor. It really does an amazing job. Has lots of power, lots of speed, but still very nice efficiency too. So, if you haven't already downloaded the plans, go to the link below, download the plans, and get your materials in order, and we'll get started. The first step after you've gotten your materials and your plans is to do the hardest step, and that's going to be the wings. This is going to be your most challenging step because it has an airfoil to it. Now, if you built the baby blender before, the process is going to be the exact same, so you'll be very comfortable. But if you haven't built the baby blender, just go ahead and take these couple careful steps to make sure you have a good result. And that's going to be to transfer your wing design onto your Adams foam board. The marks we're going to want to make for the wing that goes horizontally along the wingspan is going to be at 3 inches, 7 inches, 9 inches, 9 3/4, 10 1/2, 11 1/4, 13 1/4, and then 16 inches. The wingspan is 28 inches wide. We're going to start by cutting the outer area of the wing. Now when you do this, go ahead and start your cuts a little bit before your mark and end them a little afterwards. That way you don't get ratty edges. Take your time and make sure that your marks line up with the lines. Because this is going to be folded over, it's very important that you do this as accurately as possible, so when your wing folds over, it's the exact same on both sides. Easy method to do too is if you put your razor blade down on the mark, bring your ruler to it, it actually gives you the ability to go right on that line if you're unsure. Long, nice, smooth cuts with the sharp X-Acto knife will give you the best product at the end. We're going to go ahead and take the mark line for our leading edge, and we're going to cut a 50% score cut going right down that line. Take careful time to make sure you're right over top of that line and that your measurements are all accurate. Reason being is if it's slightly off, your wing's going to fold crooked, and that's not a good thing. Once you have that, go ahead and fold back. If you did it right, the sides of the wing should be nice and flush with each other. If it's cut crooked, what you'll want to do is you'll actually want to go ahead and go into the area and cut that area off so it stays the even space now. If you go ahead and do it later when you have your airfoil, it's going to be much harder to do that. On the trailing edge, which is actually on the very top of your paper, cut a long, wide bevel, just like we did on the baby blender, roughly 3/4 of an inch to an inch wide. And don't be too concerned about getting this absolutely perfect. Use a nice sharp blade, but if it's a little ratty, you can always clean it up with 120 grit sandpaper on a sanding block, or just keep shaving it away. No one's going to see this part on your plane because it's going to actually be sealed down. All we're doing is trying to take material away so the top surface of the wing blends into the bottom as smoothly as possible and looks as nice as possible. Make sure you guys change your blades a lot, especially cutting bevels. It's going to chew up the blades really, really quickly going through that foam. I really don't know why, because it's such a soft material, but it dulls these blades out immediately. So don't be afraid to change blades a lot. The material's cheap. Blades aren't that expensive. Your product at the end is going to be much better. Now what we're going to want to do is that score line that we cut 50% through, we're going to fold that back. And just like we're making a hinge line, just the same as the way we were building with the baby blender wing, we're going to go ahead and cut a 45-degree bevel on both top and bottom of the wing, making sure you don't pass through that center layer of paper. So take your time, and it's much easier if you lay this on a piece of paper. You can use a ruler as a reference guide on the top, but I generally just like to establish an angle with my hand and then just run along the whole length of the board until done. And this is another reason to have a nice sharp blade. If it's dull, it'll tear the paper and ball up the foam, and no one wants that. So once you establish your angle, as long as you don't move your hand in the orientation of your hand, it'll cut a nice, clean, consistent bevel. My son always tries to cut his bevels going away from him like this. That's not going to work. You always want to try to pull towards your body. I know that's kind of the way we were never taught to do. You always want to cut away from yourself. But in this case, try to get your body right over in center line and pull it straight towards you. It'll give you a nicer cut. If you did that right, your center line should look like a nice little V groove. This is where your leading edge is going to be, and this is where your wing's going to actually curve around to make the top part of the wing. The next step is to cut out your spar. Now, the spar's going to be cut out of the same material as your wing, and what you're going to want to do is cut a 28-inch by 1-inch rectangle. Before you cut the full rectangle out, it's much easier to cut the score line that your spar is actually going to fold over on because you have a bigger surface to work with. So we're going to cut 50% through here. And then our 1 inch mark, we're going to go ahead and cut all the way through. Nice thing about the spar is it makes it more rigid, and it also establishes the airfoil and gives you a surface to glue the top surface of the wing on. So it's very important that you take time and do that right. Once you have that, simply go ahead and crack this over. Make sure that lines up nice and pretty, and then we'll lay a bead of glue down, and we'll glue it, holding it perfectly flat on the building board until it's thoroughly dry. Reason for this is you don't want to have it be crooked when you put it on. Now this is not like balsa wood. You can actually form this later to make it better, but it's better if it's straight as possible from the beginning. We're going to take our spar to the front line of our spar reference point. Once you're happy with the fit widthwise, go ahead and simply lay a bead of glue down and let your spar fit firmly in place. Next up, we're going to take our popsicle stick and we're going to go along these score lines here, but we're not going to puncture the paper. We're simply just going to establish an indent that will make the paper want to fold on these lines. This will give it nice consistent creases when you establish your airfoil on the top. So do not break the paper, just simply dimple the paper. Once we've established our grooves, use a long straight edge to line up with that groove, and simply pick this up and then establish a crease line. And don't try to bend too much too quickly. Just kind of work it, and you'll find it gets easier and easier to bend as you go along. Getting these bends as clean as possible will make your wing look really nice, and also adds a tremendous amount of strength because those creases are going to give you rigidity as well too. The next step is going to be to actually start working your wing around to make the airfoil. Now we kept this groove a little bit on the narrow side. You could actually make it and chew it out even more, but I like it because it makes more of a bold nose on it and establishes a higher airfoil. So it's not just like a simple chop up and chop down. It actually gives you a nice roll on those curves. So I just like to work that around until finally we're sitting right on top of that spar and our wing is down just like that. Gives you a nice roll. Every one of these guys are under extreme amount of pressure now, and it'll give you a nice curve where every ridge is established, and that's what we want. I think the term is called turbulators, and that actually breaks up the airfoil and slows it down even more in the front, creating a higher amount of lift. And anytime you have a small little plane like this, a high amount of lift is good because it actually has a very nice glide ratio because of that. So having these little ridges on here pronounced the way they are, I think truly benefits the flight characteristics of it. Now once we're happy with the fit and the fact that the trailing edge meets down in a nice smooth fit, we're going to go ahead and apply glue to the trailing edge, the leading edge, and the spar, and then we're going to fold it over, spreading this force out as much as possible to get a nice solid glue joint. I don't go right to the edge on the trailing edge. I actually go right in the middle, and hopefully the glue will squeeze out to the trailing edge. Also a good way to keep yourself from burning your fingers. Start about a ½ inch in here, once again so the glue doesn't squirt out the edge and make a big mess. The last will be the spar. You don't need a tremendous amount of glue. Every glue stick you put in that you don't need is just extra weight. The important thing is that you have a nice solid glue joint. Alright, now we're going to go ahead and bend this around. And with this being a tapered trailing edge, it's a little bit challenging. You can't really use the ruler as well, like on the baby blender. So I just try to do is move my hands around as much as possible and keep that glue joint down. Make sure when you push your wing down that it's seated firmly on top of that spar. That's going to establish the airfoil, and you want it consistently down that spar from top to bottom or from left to right to keep the thickness in the airfoil consistent. Once we have our wing established, the reason why we didn't do our hinge lines first is if this wing bends over a little bit wider and your hinge line is on the other side of this wing cord, just say through anomaly with measurements, we're going to be in a pickle. So now we can establish where our 2-inch hinge line is and see that we're okay. Once we have that, simply go ahead and take your razor blade, cut your groove into your fuselage. This is going to be the relief for your ailerons. And I like 2-inch ailerons on this. It's a little bit wider than Bloody Mix design, but also since we're going to be flying at slower speeds, it's very nice to have that extra aileron control. You can always dial down your throws, but you can't make bigger ailerons. Alright, so that's going to establish our relief area and also the dimensions there. Now on the bottom of the wing, we're going to measure 2 inches here. Now say for some reason that it is overlapped here and it's not right on the edge like it should be, don't go ahead and build a new wing. Just simply move your dimensions back and move your hinge line. As long as the hinge line is straight, you're not going to lose much control. So matter of fact, for this one, just to show you, I'll move it back to 1 3/4 inch to give it the same dimension on both sides. We're going to do a 50% score cut, just like we do with all our other control surfaces. I'm going to crack this loose and bend it over right on top of the other surface of the wing there. Now that we have that, we can just go like we did with all our other control surfaces and cut a simple bevel cut. All set for the next side of the aileron. There we go. Now, a quick note for you guys. If this is your first swappable, one thing you're going to need to build that is not in this video is your power pod. This is what's going to go from plane to plane, airframe to airframe. So you're going to want to go ahead and build this first if you haven't already done so. The link for that is actually below this description, along with the link for the plans for this airplane. So I strongly recommend, because we're going to be using this to fit everything on there, if you haven't already built this, go ahead and stop now, go to that video, get your materials, and go ahead and put one of these together. Our next step is to cut out, if you haven't already done this, cut out the rest of the pieces. As you can see, there's only 5 of them left before you have a ready to fly airplane. But go ahead and cut these out now, because we're going to be assembling them very quickly, and it's much easier to do this with all the pieces cut out. For this step, we're going to take the rear part of the fuselage and cut a hinge line, a 50% score cut, right through the stabilizer, separating the stabilizer and the elevator. Be careful not to go all the way through, because we want to keep that paper on the top intact. Once you got that, bend it over 180 degrees and simply cut your 45-degree bevel cut like we do on all our other hinges. Now, because it's a combat plane, make sure you have good throw up and down, because you're going to want to be flying inverted in all sorts of orientations. So make sure you have good, healthy throw both ways. Our next step is to take the wing and the rear part of the airframe and put them together. Now, make sure that your hinge line and the ailerons are both facing up. If you have one like this, you're going to have a mess, because your hinge line is going to be facing the wrong direction. So make sure, since this is the bottom of the plane, you see all of your hinge lines. Now, simply push these two surfaces together. Make sure you're happy with both the fits on the top and bottom. Take some extreme packing tape, which is just wonderful stuff. Hopefully, if you guys are into the models, you have a roll that's laying around. And simply lay down your tape, keeping this as tight against the airframe as possible. Once you're happy with the fit, don't fret if you go over on the ailerons. We can always trim that off later. Simply flip this over, and this is where the flat building board is going to come in. We're going to open this up, put a bead of glue right down in that crack there, push it down on the flat building board and hold it nice and flat on the whole surface of the building board. And just take a piece of scrap foam and squeegee it smooth. Now that that's all dry, we'll go ahead and put a piece of tape on the top surface as well. We are done with this for the moment, so we're going to go ahead and set this aside. And our next step is to cut the main area of the front fuselage. This is where your swappable is going to go in, and then also your rear part of your fuselage. We're going to go ahead and just verify with our power pod that we have from our previous planes, or the new one that you've already built, that our marks line up with the marks from the plans. The reason we want to do this is everyone builds a little bit differently, and if these are slightly off, you want to cut them custom to your power pod. So if you have them in a slightly different location, say if it's a 1/4 inch forward, a couple centimeters back, you actually can model that to fit perfectly to your power pod. So those are good. Next thing we're going to do is we're going to go ahead and cut out our holes, and we're going to score cut all of these lines on both these sections. It's really important that you use a nice sharp razor blade with these while you're cutting it. Otherwise you'll get ratty, torn paper, and no one likes that. It's nice to work from the outside in, so you're constantly revealing what you're cutting, or what you just cut, because then you can make sure that your cuts are nice and parallel. If you go ahead and cut this line first and this one, you're cutting this up, or covering this up. And what causes is if you're slightly off, you won't see it until after you made that cut, so you can't address that. So pull this away. Right, now if you did everything right, what you want is you want these reliefs to be just on the inside here, because the pod is actually going to ride up against this. Because this is a combat airplane, we want this as strong as possible. So this is a friction fit. So this is going to cup down really tightly right over top of this. Alright, remember, just like on the power pod, when we glue these, we don't go all the way to the edge right off the bat. We just put a simple bead down in there. Don't try to fill up the crack. Just enough so when you fold this up, I like to leave the bottom cheek down, that it squeezes out ever so slightly. If it squeezes out too much, because it's a friction fit, it's not going to fit your pod very well. So you want just enough glue to squeeze up and around so everything has a thin coat of glue. Just like you're working with wooden carpentry. Finally, leaving one end on the building board is a lot easier than trying to bring the edges up, because you have a lot more control on this bottom plate pushing down. If you don't push it all the way down to the building board, you'll end up with a wider fuselage than you want. It may not affect the flying characteristics, it'll just affect the looks of it. We're going to do this one more time with the rear part of the fuselage. So before we go any further, one thing we're going to want to establish is that this outer pod is going to slide in nice. Now you're going to need to cut a little bit of relief for your wires here. And we're also going to want to put our barbecue skewers in. See the lines there? See lines there? And this, see this right here? It's going to go right back into here like so. Our next step is going to be to install the barbecue skewers. They're going to be our front dowels. Now to do this, we do the same process that we've done before. So if you've built any other swappables, this is going to be old school for you. Just simply line it up, turn it in, push it about an inch, inch and a quarter, 3 or 4 centimeters. Try to keep it in the center as best you can, using that point, almost like a drill bit. Now if you see it on the paper, don't worry about that, because when you put the glue in, as long as you don't push through the paper, you're going to have plenty of rigidity. As you can see, they're both about that size. Now we're going to flip it around. We'll use the dead area. We'll make our mark, and we'll cut it. Rocking your blade back and forth gives it a nice round cut. It doesn't get all burred up on you. Now we can go ahead and remove our pod. Just a little drop of glue on each one. And do this one at a time so you don't have to rush it. And don't try to force it into a new groove. Keep it in the same groove that you had before, because that was the one that worked. If it's not parallel to each other, your pod may not go on easy. Go ahead and test our fit one last time. Perfect. Our next step is to join the rear part of the fuselage to the front part of the fuselage. Now make sure this notch here is just enough so when you sit it down on a flat building board, there's no rock either way and there's no gaps anywhere. If you can move this up and down and there's slop in this, then you're going to need to readjust this or make another one, because this is very important for the strength of the fuselage. So, with this, take 2 scrap pieces of foam. Make sure that this sits nice and level. Once you're happy with that fit, simply take this out. Put glue on these joints, a nice healthy bead. Be careful not to put too much so it doesn't squeeze out and cause it to close the area that your power pod's going to sit in. We're going to go ahead and slide this in. Make sure nothing's down in there squeezing, and we'll shove these guys in here for centering. And we'll let that dry. Our next step is to install the fuselage onto the wing. And to do this, we're going to go ahead and establish a center line going through the fuselage, or through the wing. And this is 28 inches, so we're going to go to 14. And the fuselage is 2 1/4 inches wide. So we're going to go out 1 1/8 on this side, and 1 1/8 on this side. Now for you metric guys, I believe this is also 6 centimeters. And it is, so we're just going to simply go 3 on each side. 6 centimeters, we're going to go 3, 1 1/8, 1 1/8. Now that we have our marks, we're going to go ahead and test fit everything. Now it's important that we don't push down too far and cause this to bow. But we want to make sure everything is nice and flat on this. And to get the proper spacing, we're going to take this edge on the back part of the front fuselage to our seam line here. So we're going to line this up, line up our front tick marks. and everything looks really, really good. Now if we want, we can actually go back in there and draw a couple extra reference lines just to make sure that we don't move through the whole process. Our next step is to glue on the fuselage to the airframe itself, or to the wing. And to do this, we're going to want to be very strategic. We don't want to put glue up in this area because this part is going to be exposed. So what I like to do is I like to put glue on the fuselage from this point forward, but on this where it's going to be a little confusing, I'll put glue on here. Now, it's important not to put too much glue and be wasteful, but since this is a combat airplane, I'm going to go ahead and make sure I have a good secure perimeter on this, and at the same time all the glue joints are very solid without going too crazy. So let's go ahead and do that now. More glue doesn't always mean better. A hot glue works best when there's a nice, consistent, thin film throughout your whole surface. For that reason, I actually like to scooch it around a little bit too once we get it on. There we go. It's on there. Now, I don't want to push down. I'm going to put my hand underneath here, and I'm simply going to rock it back and forth just a little bit to move that glue around while it's drying. Being that this is going to be a combat airplane, we're just going to follow up with a thin bead of glue on each side just to lock everything down nice and secure. You can always take a little tiny scrap piece, squeegee the excess off. This also drives the glue down into the joint as well too, so you're removing excess but also pushing it where it needs to be. The next step is to install your servos. Now we're not going to put the vertical fins on because it sits nice and flat on the table. If we put the vertical fins on, it'd sit up in an angle. We don't like that. We want to be able to work on these control horns and servos. So now we're on to the electronics. First we're going to take the marks. If you haven't already cut out the release for your servos because you weren't sure, go ahead and do that now. We're simply going to go ahead and shoot this in. I like to keep it just a little bit tight on the servo. That way what happens is you can always chew it out to make it a little bit bigger. But a good tight fit is always nice. And keep in mind, you're going to be going actually through 3 layers of foam for this. The top and bottom of the wing, and also your fuselage. So next step after we get both of our reliefs is we're going to simply go ahead and test fit our servos. And slide that lead forward. That feels good. We're using the Turnigy 90s. They're basically the same as the Hextronic 9s. Great servos. We really, really like them. When the Hextronic 9 grams are out of stock, we basically order these ones, and vice versa. But both those fit good. Now we're ready to go ahead and put our control horns on. Now this is going to control your ailerons, and the back one is going to control your elevator. We'll go ahead and start with our elevator first. Now it's easy with this push rod here. We're going to use a slightly thicker push rod. Normally we go with as thin as possible, but because this is going to be flying so fast, we want to use a slightly thicker push rod here. You guys can choose whatever you want, but this is 1.4 millimeter music wire. And we're going to have our control horn go off to the left because we want to keep the swappable as consistent as possible so you don't have to reverse anything. And by going off the same direction, now if you guys install it where it's going to the right, take a look at previous swappables you've done and just match that. That way when you go to this model, you're not going to have to do any servo reversing. Our goal is to be able to just plug it into your receiver and go fly and have fun. So for this one, I got to go to the left. And that's what I'm going to do right now. So we're going to go ahead and mark this mark back. We're going to take our control rod and making sure that our hinge or our hole is right over the hinge line here, we're simply going to go ahead and make a mark. Whenever you put in push rods, it's important to try to be as efficient as possible with your angles and where everything goes. It's always easier to move your control horn before you glue it down as compared to after. So make sure that your hinge line and your holes line up perfectly, just like that. Alright, once we're happy with the fit, we'll go ahead and glue that in. Alright, in this case I'm going to use a ruler as a substitution to a push rod. And we'll simply install the servo arm on top. This is very similar to all the other swappables we've done, so hopefully this is something that you're very used to by this time here. It's just a matter of where to put your control horns. And because unfortunately we don't have a mechanical advantage on this, this should actually come in at a 90 degree to the hinge line. But unfortunately we can't do that because it is spread out so wide. It's just unfortunate, but it doesn't really inhibit us too much. So what I like to do is go roughly about a half of an inch in and simply lay our mark down right above the hinge line, just like that. And there's so many different control horns out. Everyone has their own favorite. These are ones that Chad actually designed and he cut out himself with the laser unit, and I really like them. So I'm going to go ahead and use these. test it real quick. Once again, making sure that the holes are right over the hinge line. If it's too far forward or too far backward, you're going to get more throw one direction than the other. And unless you want differential, it's not a good idea to do it. There we go. That's good. I'd much rather put a side load on the aileron than a side load on the control horn. It's unfortunately going to have a little bit on both, but this is, I guess, the biggest compromise, the best of both worlds. So we split the difference between it. It'll be just fine. Now we have our control horns in, we're simply going to go ahead and bend our push rods. Now this is the same process as before, and if you guys have speed clevises, I strongly recommend that you use them because you can dial everything in. And also, the idea is to take the pop from one plane to another and simply install it and go fly. So if you have all your trim set up and all your planes flying good and you set up your clevises so it's trimmed that way, you'll simply won't even have to touch your trims. You can simply go right onto it and have fun and fly it. I'm not using speed clevises, and it becomes a little bit difficult. If I get this wrong, I basically got to make a whole new control horn. But hopefully I got this right. So if you're comfortable making push rods without using them, that's fine. But truthfully, if I had them available to me right now, I would use them. We'll tape the aileron down just so it doesn't move too much while we're measuring out our control horn. I'm going to line this right over the top of the hole I want. Just carefully bend it down while it's still in the control horn. Reason being is that keeps us from getting the orientation wrong of the bend. And if you did everything right, you should have everything nice and parallel. To install the rear push rod, we're going to go ahead and use the same process as the ailerons. We're going to go ahead and get this. We can make sure that we have a nice level just by simply holding it onto a stick. With the finger. Once again, speed clevises are the way to go, but this is another technique you can use as well. And like I said, keep that back part locked into your control horn. That way you don't get your orientation messed up. We'll go ahead and do a modified Z-bend on the front. Alright, sometimes for thicker wire you do need to chew out the hole just a little bit. Give yourself some extra room. Don't go too wide or your servo arm will break. The reason why we didn't glue down our servos first is if we do need to do some fine adjustments, we can always kind of slide this back and forth just a little bit before locking it in with glue. But these are really close. We're ready to center up our servos and go to the next step. Our next step is to actually center our servos before fastening and gluing them down. So we're going to go ahead and, just like in previous steps, we're going to go ahead and make our connections. We're going to plug our aileron into our aileron, our elevator into our elevator. And keep special mind, this will be one of the first aileron airplanes. Most of the time you're plugging your rudder into your aileron on 3 channels. So don't be alarmed by that. But this actually, aileron to aileron, elevator, elevator. And we'll go ahead, flip this over, and pop these control horns off. We don't want them to be at one control throw or the other. Hopefully it should be pretty centered for you. Turn on our radio and make our connections. We have movement. So now we can go ahead and make our connections. This is where if you had speed clevises, you could simply go ahead and adjust your clevises, but what I want to do is make sure all the throws are the proper direction. And they are, but they're very extreme. There we go. So now we'll go ahead and make our sub trims. And I bet this guy can go down a little bit more. And if we're happy with the fit, we can go ahead and glue in our servo and lock in our servo arms. There we go. I like lifting up the servos a little bit so when you push it down in, it actually drags some of the glue down into the hole with it. Don't ever count just because your servo has a tight fit that it'll stay that way forever. You always want to make sure that they have some glue down there. Now if you have to glue on the side surface, it's also important that you remove the sticker and scuff it really, really well. That gives a good glue joint for you. Always put your servo screws in, especially since this is a combat airplane. You don't want to have the chance of an elevator coming loose or an aileron coming loose because there's no way to fly without it. This isn't a self-stabilizing airplane, and because of that, it will lawn dart. Our next step is to actually fasten the back part of the power pod to the airframe itself, and to do that, we're simply going to go take a sharp barbecue skewer, use the reference hole. Now, if you've built along with the plans, the reference hole should be very close to both sides. So it's much easier to go from one reference hole to the other, and then go clean through, than to try to pop through the layer of foam and go out to the other side. So just go one side, and then go to the other. Keep in mind it's going to be hard at first to get through all the foam. And then simply pass it on through to the other end. Now with this one, it is a good idea to keep the pointy side because it's much easier to douse. So we'll go ahead and keep it like that. And your power pot is on. And the final step is to put your vertical fins on. And like I said, the reason we haven't done this until this time is because these actually protrude out a little bit, so when they're on, the plane sits at an odd angle. I'd much rather be able to flip the plane over both directions and manipulate it and get my servo arms and get my hands in here than be knocking these loose the whole time. And plus, since this gives you vertical stability, you want a nice strong glue joint. You don't want to be breaking it while you're working with it. So now this is all done, our next step will be to test fit. Make sure these are nice and vertical. Also make sure that your elevator has plenty of clearance here. If your elevator does rub on your vertical fin, just simply cut out a little bit on each side just to make room if it drags a little bit. So that fits good. Let's go ahead and glue it in. Do this one at a time and let it thoroughly dry before going to the second one. You're going to want to come back and reinforce this also with another little bead of glue on the top and bottom just to give it extra rigidity. But if you do it right, it'll be very strong. One trick in the past we've used is if you have too much slop on your wire, even though using the thicker wire gives you more rigidity, it will want to bend when it's actually coming forward. So in this case, if you're going a high-speed dive, this will want to relax a little bit on you. You can simply take a zip tie, go around your push rod, go as tight as you can without making it cinch down on the actual push rod. And then Chad Capper taught me this trick. Put a nice bevel point to it. That'll give you the ability to actually pop through. Then all you need to simply do is puncture the foam down through, take it out, put a drop of hot glue in, and then seat it down again and let it dry. This will give you the rigidity you need to not have that wire bend on you. Our airframe is virtually done, and we are ready to do the final process, which is balancing and test flying and making sure the throws are right. To do this, what we're going to want to do is make sure our power pod is installed and make sure the barbecue skewer is through on the back. And once we've gotten that done, establish a balance point, which is referenced on the plans, and make sure it balances out properly. Once you're happy with the balance, make sure your right and left aileron are proper, your elevator is proper, and that the throws are not too great. With this, I like about a 1/2 inch throw for normal cruising and a 3/4 inch for really crazy roll rates and loops. But if you go too extreme, it is counterproductive. It actually almost causes a high-speed stall. So mess around with your throws a little bit. I like to fly 30% expo on all my different throws, and it's a very docile plane to a very aggressive airplane, depending on how you want to fly it and how you want to set up your throws. If you're just learning and this is one of your first builds that are going faster, definitely start out with the smaller throws and leave the option for the higher float throws later. Well, friends, your FT Bloody Wonder is now officially done. The only thing left to do is to go test fly it, and that's what I want to do right now. But first, I want to thank you guys for watching. I want to thank Stonecap Productions for sponsoring this episode, and I want to challenge you guys to go to the forums, chat it up on the forums, and also go to the articles. There's a lot of amazing authors with so much more talent than I'll ever have that are posting incredible articles. One of my favorite ones is the H-Virus by Jake Wells. He's just doing amazing stuff with that H-Quad. And Jake, good job. Thank you for sharing your knowledge and everything that you're learning in the process. And please, guys, keep on the articles coming, and also keep rating them too. That'll keep articles like Jake Wells and Experimental Airlines and everything, all those great articles rising to the top, so whenever someone new comes along, they're going to see the best and brightest with all their free knowledge ready to go. So once again, I want to thank you for watching this episode. I want to thank you for taking the time. Hopefully you built one of these. Let us know what you think of the flying characteristics, and also feel free to show any of your improvements that you have too that you've made to this. I'm sure there's a lot more that can be done. But in the meantime, I'm going to go fly this now. Go. Flies good.